tomorrow. Today and tomorrow, we're talking about something called the chain rule, which is a way that we take derivatives of compositions of functions. What is a composition of function? You learned about it, I guess Algebra 2 might have been the first time. It's when you take a function and sub it into another function. Okay? So, for example, if I had these two functions, f and g, and I ask you to find f of g of x, that's how we say that, that's not multiplication. That means to take function g and plug it into f. Remember doing that? So then I would put x squared into function f in place of the x, so I would have 3 times x squared plus 2. As opposed to finding g of f, where I would put f into function g in place of x. So in this case, I would take 3x plus 2, plug it in right there, and get the quantity 3x plus 2 squared. So that's what composition of functions involves. If I ask you to find f of g of 5, then you just go to this and plug 5 in for the x's. G of f of 5, go to this composition and plug 5 in for the x's. Okay, so we're not actually going to be composing functions like that, but we're going to be taking the derivative of such functions. Okay, so the chain rule gives us a method for differentiating composition of functions. And we're going to look at a tiny little simple example to get started. Okay, here's a function. Y equals 6x minus 10. I can also think of this function as 2 times the quantity 3x minus 5. Okay, so if I look at it this way, then I could even break it down kind of more simple than that and say this is 2 times something that I'm going to call u. And u is this 3x minus 5. Okay, so I have a little baby equation 2u. What would the derivative of that be?
2.
2. What would the derivative of this be?
3.
3. And if I took dy du, which is what I found here, and I got 2, and du dx, which I got 3 for, and I multiplied them, I would have 6. Okay, go back to the original function. If I found dy dx, what would that be? 6. Okay, so what we're going to do today is take kind of a more complex equation or function and break it down into its smaller parts and find the derivative of each part, and we multiply them together to get the end derivative. Okay, and that is called the chain rule. And I believe it's called that because we just literally tack on each derivative with multiplication, so you just have like a chain of derivatives that are all multiplied together. Okay, so when we're taking the derivative of a composite function, we must take the derivative of the inner function with respect to x and the outer function with respect to the inner function. Bottom line, we take the derivative of all functions. All right, so let's look at example 1. I want to find the derivative of this function here. If I think of this as something being cubed, how would I take the derivative of something being cubed? I could, but what if I didn't want to? Multiply it by 3, and then reduce the exponent to 2. Okay? Now, I also have this inner function of x squared plus 3x that I will have to, at some point, take the derivative of. And what is the derivative of x squared plus 3x? 2x plus 3. Okay, so this is how we're going to do it. We're going to start with the outer function. And when I look at this, I would think the outer function is that cubed, the power. So I'm going to take care of just that derivative first. So I will bring the 3 down, and then all that stuff is now raised to the 2. Notice I didn't change this or take its derivative yet. So all that represents is the derivative of something being cubed.
Could you cube it all and then do the
Sure, if you wanted to. And then tack on with multiplication. Now I take the derivative of the stuff inside the parentheses, which is 2x plus 3. And often we will just leave it like this or just minimally simplify. For example, I could maybe distribute this part and leave it as 6x plus 9, and then your x squared plus 3x squared. Okay, and I'm going to leave it right there.
Why would you not distribute the 3?
Because this is squared, so if I were going to distribute everything, I would have to FOIL that out first before I distributed anything. Now, please excuse my dear Sally, the exponent would have to be dealt with first. So, but normally we'll just leave it. Okay, so who has a question?
That's
Yes.
your answer?
That's my answer.
So it has to go to the 2x plus 3?
Yes, because I can't distribute 3 here unless I raise it to the 2 first.
Okay. So if you did raise it to the 2 first, it would go to the first.
Then you could distribute that 3. Yes.
So when you find the derivative of the inner function, you can't just replace the inside with 2x plus 3.
Right. Because each step you're taking the derivative of one function at a time. So when I wrote this, I was only dealing with the derivative of power of 3. So I bring the 3 down, leave all that stuff squared. Then I multiply by the inner function derivative.
So it's the derivative of the outside times the derivative of the inside.
And sometimes we might have 4 functions. You just keep going.
If we left it as that up there, it'd be right too.
Yep.
So how do you know how far you want to split?
Until you've taken the derivative of everything. We're not going to have that many steps today. I think the most we have is 2 or 3 today.
This part.
Oh, how far to simplify?
Yeah.
I usually don't simplify very much. You'll see as we go through these how far I'll simplify. I just look for obvious things to simplify. Okay. I think you'll get a feel as we go through. You can ignore that. We kind of already talked about that at the top. Okay, I do want to look at this fancy formal definition, and then we're going to come back to it in a minute, and I think it'll kind of explain itself a little bit better. If f is differentiable at a point u equals g of x, and g is differentiable at x, then the composite function f of g of x, or can be written f of g of x, is differentiable at x, and f prime of g of x equals f prime g of x times g prime of x. In Leibniz notation, if y equals f of u and u is g of x, then dy dx is dy du times du dx, where dy du is evaluated at u equals g of x. Yeah. We'll come back to that in a minute, okay? All right, let's work through some more examples, and then maybe, hopefully, that will make a little more sense. Okay.
So on the last one, could you put u to the very third and then how they do it?
Yes. So I'll do it both ways on this one. Okay, so do you recognize that I have 2 functions going on here? I have something raised to the 10, and then I have the 2x plus 5. Okay, so I have done a composition of functions. I plugged something into x to the 10, and I want to find the derivative. Okay, so first way we're going to do it, I'm going to use this u concept. So I'm going to break it down even simpler and say this is just u to the 10. But then u is 2x plus 5. Okay, how would I take dy du? That means take the derivative of y with respect to u. It would be 10u to the 9. Okay, if I wanted to find du dx, that means go to equation u, find the derivative with respect to x. That derivative is just 2. Okay, now putting all that together, dy dx would be 10. I'm gonna break it down a little bit smaller, and then I'll get there. So I'm going to say, all right, I'm going to multiply those together, which is 20u to the 9. But notice I wanted the derivative with respect to x, and this doesn't have x in it. So the last step, I'm going to go back and replace the u with this. Okay, that's one way to do it. Let me show you another way, and some of you might prefer that. Do you have a question? Okay, so here's the other option. Look for the outer function. The outermost function is something being raised to the 10. So when I take a derivative of power 10, I bring the 10 down in front, and then whatever's being raised is now raised to the 9. Notice I did not change this. I'm only dealing with the power of 10 right now. Bring the 10 down, subtract 1 from the exponent. Now, tack on with multiplication the derivative of what's inside, which is 2. And I will get the same thing. Okay, I usually approach it this way, but if you kind of like that breaking it down with the u, then that's just another option. Yes?
You're only multiplying the 2 to the number on the outside of the
Okay, yes. So we're going back to some algebra rules again. So this is 3 things being multiplied. The 10, the 2, and this quantity being raised to the 9. The only 2 things I can multiply are the 10 and the 2, unless I want to multiply that out 9 times. No thank you. Then I could distribute the 20 to all that. So, yeah, I would definitely stop there. Yes.
Okay, so on the first way that you did it, if the derivative to the second function is 2,
Mm-hmm.
why couldn't you plug the 2 in on the top, like 10u to the 9 on the right?
Because we've already established that u is 2x plus 5. U is going to be that inside function. This is just the derivative of the inside function.
But on the third step that you did, why are you multiplying it on the outside? Why couldn't you just put the 2 in for like 10 times 2 to the 9?
Oh, you could. Yeah. Because when you multiply something, it doesn't matter what order you multiply it in, right? So, yeah, you could write it that way. You would still get 20 and u to the 9.
So is u equal to 2 or is u equal to 2x plus 5?
U is 2x plus 5. Because we established that right there. This is the derivative of u. Okay? All right, let's look at the next one. What's my outer function? The square root. Before I take the derivative of something with a square root, I will rewrite it as a power of 1/2. So I'm going to rewrite this as 4x plus 7 raised to the 1/2. Okay, so now it's a little bit easier to see. Oh, this outer function is that power of 1/2. Okay, so my derivative will be bring the 1/2 down, raise all of that stuff to the negative 1/2. Where did I get negative 1/2? 1/2 minus 1.
Times 4, so then that equals y prime.
Sorry, Cole, we'll get back on track. Times 4, which is the derivative inside. Okay, now this is something I would simplify. Let's multiply 1/2 times 4.
2.
2 out front. Okay, now I'm going to do a little finagling with this power of negative 1/2. An exponent of 1/2 means what?
Square root.
Square root. What if it's negative? What can I do to make it positive?
1 over the square root.
Move it to the bottom. You got it. Is 2 raised to a negative power?
No.
2 over 4x plus 7 to the positive 1/2. And then I'm going to simplify one more step. Now, do you? Yep, nope, it's all cool. Yep. First part, we were talking about all the rules that teachers told you couldn't do, or how we drilled into you reduce, and now we're like, who cares?
Leave it as that, the first one.
I was waiting for that question. It is perfectly fine to leave it like this, but it is equivalent to that.
But it's illegal.
It's illegal. It is perfectly fine to leave a fraction unreduced with a radical in the denominator. You can cross over an asymptote. You can have a negative under a square root. All those rules that your math teachers said, can't do that, can't do that. Yeah, imaginary numbers. Remember when you dealt with imaginary numbers? What?
Would you take the answer above the 2 and put
It'll take any one of those.
Even on the like,
Even that one.
no, the one
Oh, that one? Yeah, it's not wrong. That just like is yelling at me like, please multiply these.
If you do that where you split it into the U and the
I
I,
like the first one better.
Okay, so how would we do it with the U?
would it be y times the square root of U? Or y equals the square root of U?
Hang on. I would say y equals, I would just go ahead and write it u to the 1/2. But u is 4x plus 7. Okay, now I'm going to take the derivative of y, 1/2 u to the negative 1/2, and I'm going to multiply it by the derivative of u, which gives me 2u to the negative 1/2, and then we plug u back in.
That's the other way.
Okay.
And we end up with the same thing.
Okay, cool.
But you know, our brains work differently, so if you prefer it that way, go for it.
Let's see if we can do
Okay.
number 1.
Oh, go back.
Yeah, take a picture of it. There we go.
I often wonder, so many times during the day I see people take pictures of something up here, and I always wonder, like, are they really going to go back and look at that?
Yes.
Yeah. Like homework, yeah.
Okay, I have two options on this one.
You do 6x.
What's one?
6x minus 3 to the negative first.
Alrighty, that's one option. Rewrite it as 6x minus 3 to the negative 1. And then I'm going to do the power rule derivative and then derivative of the inside. Let's just keep going with this and then we'll talk about the other way. Derivative is power comes down. All that stuff is now raised to the negative 2 times 6. Okay, now surely we'll multiply that and make it a negative 6 out front, right?
Yep.
It is. I can hear it. I bet they can hear it next door.
You can put it at the bottom too.
And we could put it in the bottom. Negative 6 up top. Why is that negative 6 not moving?
The square is not 2.
Yeah, that negative 6 doesn't have a negative exponent. You're only moving what has a negative exponent. You don't have to, but if I didn't have a calculator, like if it was a non-calculator question and I had to sub something in, I'd prefer it to be like that than like that. Okay? Because if I had to sub something in, like finding something to the negative 2,
Oh,
mentally is just sort of messes with your head. So
How do you do it, though? Like without putting it?
I would do this. Like
Okay.
that's what I would have to do.
you can't.
Or if it's
the other
multiple
way.
choice.
Yeah, at some point you would move it to the bottom. Yeah, if it's multiple choice and you're just having to match it to something, then you need to know that those are equivalent. Okay, so that's option 1. What's our other option here?
Y equals.
Yesterday, if I had given you that problem on the test, you wouldn't have done it this way. Quotient rule. Oh my goodness. Derivative.
Like, why are there so many ways to find a derivative? That makes no sense.
I saw, but mathematically, that is the same as that. So just rewriting it lends itself to another rule.
The derivative of top is 0.
It is. Okay, so now it's Jonah getting us back on track. Low, D high, and you're right, that's a 0.
Prime times Z
Minus high, D low.
All over the bottom square.
Okay, but what is 6x minus 3 times 0? Yeah, all that's just 0, so I just have a negative 6. Look, that was easier. We got there a lot quicker, didn't we? But it's the same.
So it's really just if you pick the right one, depending on.
Well, they're both right. It's
Yeah.
just which way your brain goes with it, you know?
I'm just saying, like, you can pick the wrong way and get it wrong, but there was a lot of other ways.
If you made a silly mistake, you know. Okay, next one. What are we gonna do? Who said that?
It's not
Cammy, what'd you say? Product rule. Yes. Okay, now you don't have to if you are willing to multiply 4 of those together and then distribute an x squared, then knock yourself out. But I'm going to use the product rule. Oh, that's all going to be part of it. Worked into the product rule. Okay? All right, so here we go. Here's u and v. The derivative is u prime
2x.
times plain old v, don't change it, plus u v prime. Now v prime is involving the chain rule. Because v, I have to bring 4 down, 2 minus 8x is cubed, but I also have to multiply by negative 8. Okay, let me write this out.
Why do you also do negative?
Okay, let me write it all out. This is u prime times v. I think we're all okay with that part, right? Okay, plus u. All of this is v prime.
All over.
Okay, hang on. Yes, I do have a denominator.
I know that she's.
So v, remember, look, is that 2 minus 8x to the 4. But if I'm taking the derivative of it, I've got to deal with the 4, reduce the exponent, and then take the derivative inside.
Oh.
Over.
Hold on.
Oh, we can pause. Wait, over?
2 minus
Oh,
8
my bad.
to the 8.
I was buying into your quotient rule. Yes, never mind, I'm done there. Huh?
Yeah, I keep doing the closer rule.
What
Hey.
now? Say that again, Cammy.
Why, when we take the derivative of the whole thing, why we also take the derivative inside if we already took the derivative of the whole thing?
Because we did not yet take the derivative of 2 minus 8x. We did not. This was taking the derivative of the power of 4, then derivative inside.
So, like, it would equal.
Okay. Now, I would clean this up just in the following way.
Negative 16x squared plus.
Let's leave this thing out front the way it is. But look, I have a 4 times negative 8 times x squared. That's negative 32x squared, 2 minus 8x cubed. I would leave it like that. Doesn't that look cleaner? Who has a question? Who said, how did she? No. Nope.
Never.
But that's a good thing, dude. Like, usually in math, you do something and then you kind of move on to something else. Like, we just keep building. Yeah, product rule is not going away. So learn to love it. Mm-hmm. All right, moving on. But, what do you mean the rule we just learned? Expound it down? We did do that where we brought the 4 down. Oh, just alone? Because our functions are getting more complex. Yeah. More steps. Yes. Yeah, there are 3 functions involved here, really. Okay, so how would I start out on example 6? Bring the 5 down. 5 times all that stuff raised to the 4. Yes, so now I jump inside the parentheses, take the derivative of that, but it's a fraction, so the derivative of the inner function will need the quotient rule.
Okay.
And this is just multiplied. Chain rule, you just tack them on with multiplication. Okay, so that alone is just the derivative of the power of 5. Now, derivative of a fraction, product rule. Low, d high, minus high, d low, over the square of what's below. Okay, don't you tell me we're going to leave it like that.
That's your answer.
But look at this numerator.
Right.
Look, could we clean that up?
Yeah.
Wait, so that, you're multiplying that one and that one?
All that's multiplied.
That could be your answer.
Wait, why? Yeah, let's just leave it. I don't understand.
Okay, what?
Why don't you just, why do you have to multiply them?
Because that's what the chain rule is. You find the all derivatives, multiply them together.
Why couldn't you just like do the derivative like that and then do the derivative of the outside and like put it on the outside? You see what I'm saying?
I mean,
Like,
put it on the outside.
so like that one, put a 5 and raise it to the 4th power.
Distribute the 5 here? No. You could. Because it's all multiplication. Yeah, you could.
So that is none of that, just that.
Let me look at it more closely.
Okay, I like that doesn't exist. That's just,
Oh, no, you lost. The quotient rule isn't being raised to the 4. Quotient rule has to stand off on its own. I'm not raising this to the 4th power, just that one is to the 4.
I thought the quotient rule was the derivative.
It is.
Abby, you know how we had the
You're not raising the derivative.
we had to find this derivative and multiply it. Yeah. Basically, this whole thing is like that number, but this one's just like a simple. You see what I'm saying? No, but it's okay.
Okay.
I'll figure it out.
Okay, watch this. This is 5.
Just give it a
Sub-
day and it'll sink in.
See if this makes sense. This is 5 times something to the 4 times the derivative of that something.
It's not. You're not raising.
Oh, okay.
Does that make sense?
They're two separate things.
That's what DOIDX means.
Okay.
Okay.
Mm-hmm. Find the derivative of y with respect to x. Okay, look at this numerator that I expanded. What happens if I clean that up?
20x plus 5 all over 5x plus 2 squared.
No, the 25X is canceled.
Oh, wait, no.
25x is cancel. 15. Okay. All right, y'all
Dang, what did I do?
don't buck me on this, okay? Don't buck.
Wait, why is it not mine?
If you buck someone, like you go against them, you fight them. No.
We always used to do that.
You're just doing too much now.
This is a lot. Okay, this is a lot, but I just have to show you.
Then you can combine the bottom.
Are we okay with what I just did?
No.
Okay, all I did so far,
So you can do that. Put
Is-
the 4 to the each one.
yeah, because if you have x over y cubed, that's x cubed over y cubed.
So the 5 goes to the top and the bottom? Just the top.
Think of that as 5 over 1.
And we multiply that to equal 5 times 15 is
What's 5 times 15?
60 plus 15.
I see what you're.
Wait,
75. Okay, watch this. First block didn't like it either.
understandable.
I thought it couldn't do that. Because they're not commenting on it.
I'm not adding or subtracting.
Doesn't matter if
It's the algebra rules that are hard.
You leave it as that or
The last part makes sense.
Yeah, I mean, if any one of these is right, okay, I really like that one just because it's nice and clean and simple. But is that wrong? No.
I'm gonna go with the not wrong. I'm just
But when I see something like that, I don't know. It's just kind of wanting to be reduced, right? Screaming at me.
I'll just leave it as that one.
Your homework's on this sheet. All right, but can y'all see that that's equal? Like, that's some awesome algebra rules at use. All right, one more. 4 more, really.
Oh, no.
Okay. This is like we have done before. Like, you don't know what the function is. You're just given some values. Here's f of 2, here's f prime of 2, etc. Okay, so if I want to find the derivative of f times g at x equals 2, how will I do that?
You probably want to rule.
Okay? So tell me, let's just use like f and g here. So tell me what it would be.
G prime
Use f and g for me if you can.
It'd be f times g prime plus g times f prime.
So it'll be f prime. So
Or you can start that way.
times
Yes.
3 minus negative 3.
Okay, so it doesn't matter which term I start with here because addition is commutative. So if you did the f prime g first, you are perfectly fine. Now the next step, I'm going to replace the x's with 2's. Okay, then I'm going to go up and hand pick all these values. So f of 2 is negative 3. G prime of 2 is negative 2. F prime of 2 is 6. And G of 2 is 3. 6 plus 18, 24. Okay, so you could have done that yesterday, right? That's nothing new right there. Okay, what will we do for part B?
Quotient rule.
Quotient rule. Okay, so using our f and our g, I would have g times f prime, that's low d high, minus f g prime over okay with that setup. Okay, replace the x's with 2 because the whole thing is find the derivative at x is 2. So g of 2, f prime of 2, and then last step is go up and get these numbers from our table.
It would equal 12 over 9.
So that's 18 minus 6 over 9. Yes, 12 over 9.
Which reduces to 4 over 3.
Okay. Question. All right, what do you think we're going to do with C?
You do
You
what
do
you do.
take the 3 out and throw it.
Yep, we got to deal with that cube first. Bring the 3 up front, and then what?
And then
F
write
of X.
f of x to the square and then multiply it by it. And then do all the 2 values.
Okay. Is everybody okay with that setup? Bring the 3 down. F of x doesn't change. It's now raised to the 2. Then we multiply by f prime.
Yep. It would equal.
Okay, so like you said, let's put our 2's in there. And then we'll get our numbers. Okay, so f of 2 was negative 3. F prime of 2 is 6. So that's 3 times 9 times 6. 54 times 3. Okay, now, before we do D, I want to look at what we just did and go back and look at that crazy definition again. All right, so what I did is I dealt with the 3 first, and I did not take the derivative of this yet. Then the last thing I did is I took the derivative of what's inside. Okay, so on the definition, if I'm taking the derivative of a composition, I take the derivative of that outside function, don't change the inside function, multiply by the derivative of the inside. Okay, so let's apply that to this. What's the outer function? F. We have to take the derivative of f with respect to that inner function. Derivative of the outside with respect to the inside, now derivative of the inside. So if you were wondering why that f prime of 3 was in the list, you're about to find out. F prime of g of 2 times g prime of 2. It's the derivative of the outer with respect to the inside, just like we did up here.
So it's just f prime of f prime of x.
F prime of g of x. And then x becomes 2. Yes, Cammie?
Why aren't you using brackets?
Oh, I can. Brackets, parentheses, same thing.
I thought you weren't. You had to use brackets.
No. I could use 2 sets of parentheses. Yeah, sometimes I just go back and forth. Okay, so now I have f prime of g of 2 is 3 times g prime of 2. Okay, well, f prime of 3, there's why that oddball was at the bottom. And g prime of 2 is negative 8. Woo! John, did it make you collapse? All right, your homework is just on here, nothing out of the textbook. The circled problems are what I want you to do. Okay? On the back, the last one where we use these tables, the answers are there. I just forgot to white them out. So those answers are there so you can check them. Okay? I will leave my answers to the rest up here on the cart. So you can come and check. Yeah, but the answers alone aren't really going to help. You got to set it up.
I'm saying there's no answers to the front.
No, that's correct. But I'll put my sheet up here so you can check them. What, Johnny?
Is this the same as the homework?
No, it's a similar sheet tomorrow. Tomorrow we're going to throw trig functions into the mix.
Can I see
But
them?
same chain rule, so we'll still be absorbing it.
I think the trig functions are okay without them.
Well, I'm going to overrule on that one.
So